this webinar where we will dive deep into the latest research on population and demography and environmental change. This seminar is organized by the Royal Swedish Academy of Sciences, more specifically by its Environmental Committee and the Bayer Institute of Ecological Economics. My name is Agneta Sundin and I work at the Bayer Institute. And I'm here joined by a few friends only in the completely refurbished Bayer Hall of the Academy, which is waiting to be buzzing with activity very soon in the future, we hope. We have a great lineup of speakers these coming 2 afternoons, all leading scholars in their respective fields, and they offer very many different perspectives on the subject. But first of all, the Secretary General of the Academy, Göran K. Hansson, we welcome you all. And after that, Ann-Sofi Crepin of the Environmental Committee will give a short background to this event. Welcome, Göran K. Hansson.
Thank you, Agneta, and hello, everyone. A very warm welcome to the Royal Swedish Academy of Sciences and this symposium on population and environmental change. We appreciate very much that all of you have taken the time out of your busy schedules to participate in this discussion about critically important topics. And as Agneta said, we would have wished you to welcome you here in the beautiful and newly refurbished Academy building. But the corona pandemic is preventing that, just as it has destroyed so many other plans that we have made in the recent past. We hope that things will get better with time. As we all know, we live in a new geological era, the Anthropocene. And it's scary when you realize that our species influences the environment on a geological scale. And it's the first time in the history of our planet that a single species has an impact on the Earth as a whole. The concept of Anthropocene was formulated by the late Paul Crutzen, who died earlier this year. He actually worked at Stockholm University just across the street from here when he started his pioneering work on atmospheric chemistry that led to the Nobel Prize in Chemistry in 1995. Crutzen was also a member of our academy. And being a visionary, he realized before anyone else that our way of life impacts not only on the local environment and in the micro scale, but on the Earth as a whole. This is, of course, to a large part due to our use and abuse of natural resources, such as burning fossil fuels. Now, life on Earth is not bad, at least not yet. The last decades have witnessed remarkable progress and improvements for most people on the planet, as was illustrated so well by another one of our members, the late Hans Rosling. People are healthier, live longer, and have higher standards of living than ever before. And there are more of us on the planet than ever before. So the connection between population density, lifestyle, and environmental impact is obvious. And now the challenge is, of course, to propose working conditions on Earth that does not lead to further environmental deteriorations. And that's your job for the next 2 days. I'm happy that our distinguished guests have accepted the invitation to speak at this meeting. And I'm also glad that we have a great set of panelists from Swedish institutions who will participate in the discussions. I'm indebted to the staff at the Academy and the Bayer Institute for setting up the meeting. And I'm very happy that we have a large group of participants joining us over the web. Again, most welcome and have a great meeting. Thank you.
Thank you so much, Göran. And now I will hand over the floor to Ann-Sofi Crepin, who is the Deputy Director of the Bayer Institute and also a member of the Environmental Committee. Welcome.
Thank you very much, Agneta. So like Göran and Agneta, I also want to welcome you warmly to this webinar. And this event is jointly organized by the Environmental Energy Committee of the Academy, together with the Bayer Institute of Ecological Economics. About 2 years ago, we started a discussion in the committee on the topic of population and environmental change. And several of us during that discussion felt that population was often mentioned as being the elephant in the room when talking about environmental change, but also often with a rather simplistic arguments or no further discussions. So we wanted to do something about that. And 3 of us were trusted with the task to organize a scientific event around this topic. So in addition to myself representing the Bayer Institute of Ecological Economics, this small scientific committee consisted of 2 members of the Academy's Class 9 on Social Sciences, Elizabeth Thompson, Professor Emerita of Demography from Stockholm University and Professor Emerita of Sociology from University of Wisconsin-Madison, as well as Thomas Aronsson, Professor of Economics at Umeå School of Business, Economics and Statistics. So we wanted to unpack the complexity of the interactions between demography and the environment and discuss them from multiple perspectives. Some aspects that we thought might be particularly important included how population dynamics influence carbon emissions, but also land use and our use of natural resources due to more people on the planet and their increased consumptions and activities like global trade, for example. We also wanted to understand how change in the environment could feedback on population dynamics. Could migration be a way to adapt to climate change if some regions becomes more difficult to live in? In what way would environmental change influence the current global urbanization process? And could urbanization have environmental impacts that would be important to consider at a global scale? How can we think about population environment interactions in a global Earth system perspective, for example, or in relation to food production and economic development? And what are the ethical considerations involved with these interactions? Because it implies interactions between poor people in some regions of the world, rich people in other regions of the world, and also people today and people tomorrow who are perhaps not even born yet, but will feel the impact of what we are doing today. So we hope that today's and tomorrow's discussion will shed some light on some of these issues. And also, before I leave back the floor to Agneta, I want to say that this event is funded by the Crawford Foundation, and we thank them very much for their contribution. And also the event couldn't have taken place without the invaluable organizational help from Peter Brandén and Carmila Grunditz, as well as the moderating skills of Agneta Sundin. Thank you for your support, and Agneta, the floor is yours.
Yes, thank you so much, Ann-Sophie. And now it is, well, first, before I introduce the first speaker, I will have some instructions to the audience. We very much invite you to pose a question on the Q&A function on Zoom. So this is only for you who are partaking via Zoom. But it's open during the whole webinar and the panel tomorrow, and we will try to pass on as many questions as possible to the speakers and the panel. The chat function is not available for the audience. Now, it is my great pleasure to introduce today's first speaker. Professor Leiwen Yang is a senior associate and advisor to the Population, Environmental Risk and Climate Change Initiative at the Population Council in New York. And he is also professor and founding director of the Asian Demographic Research Institute at Shanghai University. A leader in population, environmental and climate change research, Professor Yang was a lead author of the Intergovernmental Panel on Climate Change, the IPCC assessment report. So Professor Yang, the floor is yours.
Thank you very much, Aneta. Thank you again for the invitation. I'm very glad to be part of the very important webinar. I'm very glad to talk about population dynamics, carbon emission, and climate change. So I want to share my screen.
Great.
This, okay, thank you very much. Population dynamics is always considered as a key component for environment socioeconomic assessment at a global, national, and subnational levels. Examples include the UN Global Environmental Outlook, Millennium Ecosystem Assessment, and also the IPCC Climate Change Assessment Reports. This is because human population and their activities induces man-made environment and climate change. In the meantime, human society bears the consequences of the changes. There are various ideas and methods developed to examine the impacts between the population and the environment. Paul Ehrlich and John Hogan proposed the IPAD model, which decomposed impacts the greenhouse gas emission as a product of population, affluence, and technology. While it is widely used model, IPAD has its implication. It does not consider the interactions between the three components. It assumes 1% of increase in population leads to 1% increase in emission. If this is true, declining population growth may reduce emission, right? We know that this is unnecessarily true because this IPAD model considers only the average productive and consumptive behavior of the population by various demographic characteristics. Changes in population composition and distribution could also lead to quite different emission outputs, even though the total population sizes remain unchanged. Recently, UN Population Division has identified a number of demographic megatrends that are worth of mentioning. The first one is population growth. While the population growth rate declined in almost all countries, the world population will highly likely continue to grow. And the population growth will basically all grow in Africa, while almost all other regions will experience stagnant population growth or even population decline, depopulation. The second megatrend is urbanization. Majority of the population has already been living in urban area. Moreover, all future population growth will occur in the urban area of developing countries. All regions will continue to be more urbanized. Under the fast urbanization scenario, the urbanization levels of all regions will be converged to about 90%, while under the slow scenario, urbanization levels, the differences between regions will remain as big as today. The third megatrend is population aging. The children population will stop growing, while the elderly population will increase significantly. According to the conventional definition of aging, that is measured by the proportion of population aged 65 and above, all regions except Africa has already entered aged society. Population aging will especially accelerate in Asia and Latin America in the next decades. The fourth megatrend is migration. The number of international migrants and the share of the population, migrants in total population has been increased significantly. In fact, most of the population migration are internal movements. For instance, except North Africa, most of the migration flows in Africa or within the region, especially in the West and East Africa. Migration has surpassed fertility as the main driving force of population growth in many countries and subnational regions. These are the 4 megatrends proposed by the UN, but I argue that there are other 2 megatrends that we should pay close attention to, namely increasing education attainment and shrinking household size. The mean year of schooling has been increased in almost all global regions. According to the global education trend scenario, by the end of the century, more than 80% of the population, adult population, will have upper secondary or higher education levels. There are also increasing more people living in small-sized households. The US household size has almost halved during the 20th century. The average household size will continue to decline in almost all of the regions. This is a projection we made 10 years ago. Of course, the projection for China is already been proved to be wrong because the new census gives a 2.6 for China, the red line already gave a 2.6 is about here rather than here, right? Average household size for the country in 2020, combined with various variations in consumption and production behavior, the demographic megatrends could generate important impacts on emission and climate change. For instance, the carbon-intensive expenditure of American households are considerably different between the large and small size households across all age groups. The declining average household size leads to reduction in economy of scale and increasing per capita energy consumption and carbon emission. In one of the analysis, Nandis McCullough and co-authors studied the determinants of the changes in carbon emission in industrialized countries during 1970 and 1990. And if they use the population size as the demographic unit of analysis, use the IPAT model, about 1/3 of the greenhouse gas emission increase is attributed to demographic factors. If you use household as the demographic unit of analysis, IPAT model becomes a AHAT model, in which changes in the number of households are much faster than the population growth. As a result, the majority of the total changes in emission is attributed to the changes in demographic factors. Similarly, urban households in China have substantially higher labor income per capita than the rural counterparts across all age groups before reaching retirement age. In India, the quantity and energy mix differ considerably between rural and urban, while the gross per capita energy consumption is higher among the rural households. Their energy efficiency is much lower than in the urban households because the major, almost 80% of energy sources in the rural are from biomass. Therefore, not only the total population size, but also its composition in age, gender, urban, rural residents, household size should be all considered while examining their impacts on emission and climate change. Scholars and policy analysts of environment and climate change has been improving our understanding of the complexity of population and environmental interactions. To develop the new IPCC socio-economic scenario, we surveyed hundreds of experts and request them to tell what are the most important factors in meeting the climate change challenges. Here are the two lists of meeting the adaptation and mitigation challenges. Population, urbanization, education, population living in coastal areas are considered as the most important factors. Actually, during the last decade, demographers provided a very important contribution to climate change research. It is a gold period for demographers make their contributions. This is the architect of the new IPCC socio-economic scenario, the so-called shared socio-economic pathway. I do not have time to go through the detail and believe that Wolfgang Lutz and other speakers may introduce them in more detail in later talk. I just want to say that SSPs is designed with a system of narratives about the future in addressing both climate change mitigation and adaptation challenges. Includes some quantitative projections of demographic trends, as mentioned before. The quantitative projections are made for each of the 207 countries. The chart shows the aggregate global results under each SSPs. Change in population is in red, urbanization in purple, mean year of schooling, education in green, and per capita GDP in blue. The SSP scenario and its quantitative projected results are widely used among the climate change and environmental research community. Therefore, environmental and climate change research communities has been pay close attention to the importance and the complexity of population dynamics in affecting the environment and climate change systems. For instance, at the National Center for Atmospheric Research, NCAR, and now at the Population Council, we have been developing the community demographic model that includes 4 components: the urbanization projection model, a multi-regional population projection model, a household projection model that project the changes in population size, gender, rural, urban, and household composition. The projection results are downscaled to grid cells using the spatial downscaling model. The projected demographic information are used for mitigation and adaptation analysis. The projection results using the community demographic model combined with the detailed information in household income and consumption behavior are used as input for the PAD model, which is computational general equilibrium model typically used in climate change research communities that project the changes in economic growth and the emissions. Then the results are in turn as input for Earth system models to project the changes in climate systems using this model. All the projected results in climate, population, GDP, and emission are downscaled to grid cells to determine spatial climate hazards, exposure, vulnerability, and climate risks in different parts of the world. Using PET model, we study the potential impacts of population dynamics on emissions. We compare the UN population projections under the medium and high and low scenarios. Studies reveal that meeting the unmet need for family planning would generate the same differences of UN population projections between the high, medium, and low variance. It shows that by the end of the century, the global population will be between 7 and 14 billion. And between the high and the medium scenarios, the differences are largely from China, India, and other developing countries, very little from developed countries. The projection results shows that the net impacts of population differences between the high and medium scenario will lead to 1.7 gigatons less greenhouse gas emissions in the middle of the century and 7 gigatons less emission per year by the end of the century. A large share of the differences will be from China and India, while the other developed countries will account for a large share of the differences, even though their contribution to population differences are small, mainly due to their high consumptive levels. Although it will not solve all the problems, slower population growth does help mitigate the climate changes. We also explicitly examine the net impacts of population composition changes on emission. This chart shows that aging leads to low emissions, while urbanization leads to higher emissions. The effects also vary across regions. The impacts of urbanization in China and India are considerably higher than in the US and European Union. The impacts of aging will be large in China, EU, and USA, not much in India. In the recent project, we also look at the effects of investment in education. Under the rapid central and stalled education transition scenarios, because the differences in fertility rate and mortality levels between the population in different education levels, which will lead to different population growth results. Accounting for the different population results and their labor productivity of the households by education, we project the changes in carbon emission. It reveals a slightly higher emissions under the fast education transition scenario, mainly because the high labor productivity. You should note that the results do not consider some factors that might not be very significant for now, but might be important for the future changes. For instance, we do not account for the differences in consumption of the households by education. But in fact, the differences in consumption patterns may become more important in the future. This chart, for instance, shows the results of household expenditure shares on food in 4 Asian countries: Nepal, India, China, and Korea. It is clear that as education level increase from illiterate, elementary, and secondary, tertiary, households disproportionately spend less on food. Similarly, as education increase, household proportionally spend less in energy consumption. Therefore, as population consumption by education, as population composition by education changed, their consumption patterns may also change, which may lead to different emission scenarios, which was not included in the current simulation yet. More importantly, investment in education will substantially improve the population's capacity to cope with climate change impacts. For sub-Saharan Africa, the adaptive capacity measured by Human Development Index will increase in the future decades. However, under the stalled education scenario, the Human Development Index will remain as a medium level. Compare the results under the fast and central education scenarios, it will reach high and very high Human Development Index area. This is not only the case for Africa, but also for the rest of the world. For example, in India, it shows the similar results. So the takeaway message: population dynamics plays a very key role in meeting climate change challenges. Changes in population size, composition, and distribution are important for energy consumption and emissions. Investments in education, reproductive health, and changes in consumption and productive behavior are crucial for achieving inclusive economic growth and sustainable development goals. Thank you. Thank you for listening. Anna, you are mute.
Can you not hear me?
Yes.
Can you hear me now? Great. Thank you so much again then for this interesting overview of the big megatrends when it comes to population change. And one of the upsides of not being able to meet in person in this room is that we have many participants from all over the world, which is really nice. I looked over at the list of people who had signed up, and they seem to be distributed all over the world. And some of them have questions also, which I would see if I can find some of them for you now. Just bear with me. Yes. So I have one question here that some of the trends are almost 2 decades old, i.e. household energy use in India, for instance. How confident are we that these trends are persistent?
Yeah, that's a good question. It's sometimes the household income expenditure survey data are quite difficult to get. In general, this is something like the work like we did about 10 years ago. And I believe that the differences between rural urban in China, in both China and India now, are largely reduced. So the differences will not be the projection results will not be as significant as it shows here today. But I believe that this kind of differences in other less developed countries, in many, sub-Saharan Africa, the differences are still quite small, big. And I think that in general, the trends, considering the impacts of urbanization, will still be there. But maybe the differences may not as big as it shows in that analysis published in 2012.
Right. Thank you so much. And in connection with that, I have a question also. In your projections, do you take into account how climate change and other environmental changes can influence the predictions on population growth, rather than the other way around, so to speak?
Yeah, and you're right. Over the past decade, most of the work we only look at one direction, how population change affect climate. Now there are more research come out and shows climate change will also affect the population dynamics, including, for instance, the flood and droughts that may lead to population migration, right? And migration becomes a coping strategy in many countries. That will affect the population spatial distribution. And also climate change also affect fertility. There are more works come out and shows that in Bangladesh, for instance, flooding cause of the change in reproductive values and lead to fertility decline. But in some other countries, it shows opposite results. So that's something like, we still need to collect more evidence and put it into our scenario development and put it into our projection. Yeah, that's a very good question.
Thank you. And now we have a question from the audience again. How come aging is expected to lead to a decrease in CO2 emissions?
Yeah. So the short answer is that it mainly because of the productivity. And if you have a population aging and the share of a labor population will decline. And that will induce a slower economic growth. But of course, the world now has been changing, right? Postpone retirement age may cause some changes in that direction. So that's something like, well, we are still trying to account for the impacts of postponing retirement age into the results. But in general, that's the reason.
Thanks. Let me see. Next question. What is your advice on tackling this issue of higher education equals higher emission? Usually it's related to that people are not aware of their impact on the environment, or they don't care, since we are a consumer-oriented society. So what's your take on that?
Yeah, as I mentioned earlier, in that simulation, we do not consider some important factors. I guess what we mean important maybe, not so important today yet, but may be important in the future. More educated people are more productive in that way. And if we don't change the paradigm of economic growth and technology, right? And the production, the high productivity means high emission in general. That if that's the case, and improve education lead to high labor productivity, lead to slightly high emission. That will be something like will happen, continue to happen. But I want to say that we already see some evidence that education, more educated people pay closer attention to the environmental quality and take care of, pay close attention amenity and that will help them to change their behavior, change the production technology, and that lead to even in some developing countries, lead to leapfrog technology applied to their industry that also change the consumption behavior. As I showed earlier, the energy consumption, per capita energy consumption for the households of high education levels actually is lower than the low education groups, that because they use more natural growth, for instance, electricity and clean energy, and that will help to reduce the carbon emission and fossil fuel use. So I think education is the key for the future, I would say. Wolfgang Lutz will talk more about that. I totally agree that education is important, but we also need to pay close attention to the quality of education, the type of education, educated people to be more environment friendly. For instance, that's a goal of our modern education system.
And as well, correct me if I'm wrong, but higher education normally leads to, as you said, higher environmental care. Care of your environment also can lead at least to that. But I'm guessing that is very much your immediate environment and the environment you can see and take part in everyday life. But have you seen any signs that that's also true for the climate question?
Yeah, you are surely asked the right question. I say the right question. Means according to the environmental Kutzler's curve, right? That's a concept that people use very often. Assume that when you improve standard of living, then people will pay more attention to the environment. They will first pay close attention to the aspect of environmental aspect that close to their directly to their daily life and the local environment, but less to the global climate change, for instance. I think that's basically is still the case. If you look at if you use data from different parts of the world, then you can find that still, if you improve education, improve per capita GDP, you do see some improvement in environmental quality, but mostly only the local environment condition, not to greenhouse carbon emission, not to climate change yet. So that's something like that's because of largely because of the system, that our system, our economic system, our political system, put that way, and the environmental externality is not considered in the economic production, and we need to internalize that's one change, right? Internalize the environmental emission into the economic productive system. On the other hand, we need a global effort. Right now, those kind of environmental change, particularly climate change, has no boundary. It will affect everybody. And we need a joint effort from the global scale to understand the severity of the impacts and work together to help to improve the situation.
Yes, indeed. And if we talk to our colleagues in the behavioral area, then they have a lot to say about this as well, that education is not all, that there's a lot of other mechanisms that come in place. And Wolfgang Lutz, speaker tomorrow, he has a comment here to you regarding this, that education typically leads to higher income and higher income to more consumption. If you do not like the higher income, it's easy to tax it away and you still have the other benefits of education, such as better health.
Yeah,
do you want to comment on that?
Yeah, that's a good point. And we need improved education will help use more human ingenuity, right? So the change in the tax system can be one of them and can help to reduce the excessive consumption, change the consumption culture. And definitely that's one thing that we can do. But in general, improve standard of living, I have to say that improve standard of living, particularly in the least developed country, is still desired. And poverty alleviation is something like we need to pay attention to. So investment in education, in that sense, in the less developed countries, will be definitely needed.
Absolutely. Here's a question from the audience. Could you provide some closer insight on the development of population trends in Africa, and where are the regions that stand out when it comes to general trend of aging, smaller households, etc., that you mentioned? So this is really two questions in one here.
Yeah, African definitely will be the continent that the gain population. Almost all population growth, global population growth will happen in African continent. And almost all the population growth will largely, will happen in the urban area of the African countries, in the urban area. So urbanization and population aging, we already see some signs in some parts of the African countries. And changing the household composition, shrinking household size, also already seen some evidence in some countries. And maybe this is something like, inevitable. And reducing the population size also reduce the economic scale. That's also inevitable. And some people say that, divorce not only hurt the children, but also the environment. But that's something like, we need a more analysis, an in-depth analysis to understand the social changes, not only the population dynamics itself, right, but also the marriage and living arrangement. That's something like we need to do more studies in Africa as well. But we know that this is happening starting from Europe, right? The shrinking household size started from Europe, and now happened in many parts of Asia. And in Africa, we already see the signs of that changes as well. The shrinking household size changing in the marriage patterns may also affect the consumption and emission as well.
Then, of course, you can have the reverse trend due to the problem with building new housing quickly enough for the increasing population in cities. We have that problem here. So that here actually households are getting bigger again, I think, on this assumption. But this is Sweden has a very small population, so it doesn't make very big difference in the
that's definitely
global trends, I'm sure. So
that's definitely the case. When you have a high economic growth, and particularly if you have improved housing condition, that's something like happened in China, and the household formation pattern changed completely. We projected the changes in household composition in China. We assume that pattern will not change, but in fact, it changed a lot. And now, the average household size in China is as small as in the US. So that's something like we we never expected before, just 10 years ago. So society can experience that kind of a magnitude of changes that demographic projections sometimes cannot keep up with. We have to admit.
Great. Let's see if we have another question here. Well, here's a question on growth economy affects inflation, where poor people cannot afford the basic needs as well as education, especially usually in developing countries. As usually in developing countries, the education fee is quite high. How can we solve such issue? I'm not sure if you're the right person, but you can give it a try to answer that.
Yeah. So we need a policy, right? And to help on education. And if you look at the history of education, mass education always happened, not necessarily when you have a high economic growth. Mainly because of the government determined to improve education. And that's something like, I believe many developing countries can adopt a right policy, help poor people to have education, have an education opportunity. I think that's something like we can learn from the experience of many countries like Korea and South Korea and Singapore, and those other countries experience a very rapid education improvement because of the mass education policies, and that greatly help reduce the poverty levels and
provided that's the goal for the politicians in place, but which we hope will be the case in most of the world soon. I have another big question coming up here. What do you think will be the democratic change in the coming 50 years with the largest potential to influence the climate?
Yeah, that's something like, well, the group are trying to develop a scenario. And so we know that those urbanization, aging, and population growth and declining growth will happen. But how big, how deep that change will be, that's still something like we need to do more analysis to comprehend that trends. And the other possible changes, maybe from the climate or from the environment changes, is something like a pandemic. How the COVID-19, for instance, may generate impacts on population growth and spatial distribution. And we know already it affects the fertility and either postpone or just like reduce, change the reproductive values forever. And it also generated impacts on the population redistribution, because the highly urbanized area are the places endured the severe consequences of a pandemic. And we already see some out migration from the city center to the suburban area, even to remote areas. Sorry.
And also quite some effects on the housing prices also in.
Yeah. Well, that that lead to another round of counter urbanization. So that could be one question, right? The other one is that, well, this kind of a short period of time of shock, the pandemic, will lead to a long-term population changes, even add to the trends of depopulation in many parts of the world. So that will be something like a, there could be a larger.
Why is that, do you think? Sorry, why is that? That people would have less children because of the pandemic?
The pandemic, they have, there are some research and survey research, for instance, conducted by Brookings Institute in the US, ask about the reproductive values of the population. And people look at the uncertainty caused by the pandemic, the economic downturn, unemployment, and also the environmental consequences, climate change, and they look at how that may affect women's view on their reproduction, and see some significant impacts. And people, quite a number of people, quite a proportion of people stated that this pandemic may change their reproductive values forever. So we don't know.
Very interesting. No, that's very interesting. Have you, and in your field and your peers, have you now, after this pandemic, been thinking that, hey, we have to take into account more of this pandemics that can come out? Has it shaken your field, or what?
Yeah, that's something like recently I'm working on a project to understand the short-term and long-term possible impacts of the pandemic on population dynamics, population growth, change, and also spatial distribution. That's something like I'm working at and try to account for the impacts. Yeah, we are trying to do. I know that many people are also trying to do that.
So one last question before we thank you and go to a break is another quite big question. Does declining population growth and population aging, will it help solve the climate change problem?
Depends, I would say, because we know that population decline is one important factor that can lead to emission reduction, but also depends on other factors, the population composition changes, including population aging. Aging may lead to low productivity, but the world now adopt, just as mentioned earlier, Wolfgang mentioned that the population will be, although the population will be aging, but the world population will be more healthy, more educated, and so postponing retirement age is already happening, and maintaining economic growth is a goal in many countries. And if we don't have a change in the industrial structure, don't change the technology, adopt a new technology to reduce the energy intensity and carbon intensity, and maybe the answer will be no. So it really, the interactions is quite complicated and need account for the interactions between population, economic growth, and technology, and in the system. I think that's something like we need to do more analysis.
Great, and that's what you will do, I assume. And so with that, I thank you very much for your talk and for answering all these difficult questions for us. Thank you so much, Leiwen. Now we will have a 10-minute break, and when we come back, we will listen and talk to Karin Seto. So thank you very much for now. See you later. Welcome back, everyone, from this 10-minute break. I hope you now are ready to listen to our next speaker, who is Karin Seto, Professor Karin Seto, who will talk about from food systems to climate change, how urbanization is reshaping humanity's imprint on the planet. And Professor Karasetter is the Frederick C. Hickson Professor of Geography and Urbanization Science at Yale University. And we are also very lucky to have her on the scientific board of the Bayer Institute. An urban and land change scientist, she's one of the world's leading experts on contemporary urbanization and global environmental change. So welcome very much, Karen. The floor is yours.
Thank you very much. And it's very nice to be part of this webinar on this really important topic. And even though Leiwen and I did not speak in advance, I think that my talk follows up very nicely with some of the key issues that he raised. Whereas Leiwen really spoke about the population aspects, I'm going to focus on urbanization as both a population demographic change, but I'm also going to talk about urbanization in terms of a land transition as a land change process. So I'm going to start with going back in time and reminding us of this paper, this seminal paper that was written nearly 30 years ago now, where Peter Wojciech laid out this paper on what global environmental change is, really conceptualized it. And in this paper, he talks about global environmental change as having two different components. And he writes that the first component of global environmental changes are those that alter the well-mixed fluid envelopes of the Earth system, and hence they are experienced globally. So these are things like climate change, the depletion of the ozone hole, and then also ocean acidification. But he also writes that there's a second type of global environmental change, and that these are those that occur in discrete sites, but are so widespread that they constitute a global change. And in his article, he talks about land use change, biodiversity loss, changes in atmospheric chemistry. And I would argue that if he were to, or we were to write this article today, we would add urbanization as the second type of global environmental change that's happening all around the world, both the demographic change, but importantly, the urban built up environment is happening at such a widespread around the world that it is a type of global environmental change. And just to put this in a global perspective, as recently as 1950, the world has fewer than 1 billion people living in cities and towns. That was about less than a third of the global population. We're now over 55% of the population living in cities and towns, and it's estimated that we're going to add about another 2.5 billion people in urban areas. Now, I really want to underscore that these data from the UN are collected from individual countries, and there are many, many different definitions of what urban is. It ranges from population centers of 2,000 people to places that have tens of thousands of people. And so this statistic, we need to keep it in mind that this is a combination of both cities and towns. It's not just 6.7 billion people living in New York's and Shanghai's or very large cities. They're also living in smaller towns. And in fact, some of the fastest growth is happening in these smaller towns. If we translate that statistic and put it in a different context, what that means is that every day, or actually it's not every day, every week until 2050, the urban population is going to increase by about 1.3 million people. And so that means that we're going to have to build a lot of the built environment. There's going to be a lot of land use change, construction of infrastructure to house the growing urban population. And what I would like to do in the next 30 minutes or so is talk about what urbanization as a demographic and land transition, the building of the built up environment, what does that mean for land? What does that mean for resources, food systems? And then I'll end with a discussion about its implications for climate change. So starting off with land, Leiwen hinted to this, and Netta spoke about this. You know, these are data from the US. You can see that average home size has increased quite significantly from about 1,600 square feet in 1973 to just under 2,800 square feet more recently. This trend is what we're seeing all around the world. So we could replace this with Sweden, with China, with India, Nigeria. The y-axis would change, but the trend would be about the same, that average home size is increasing all around the world. And so what we're seeing is an urban aesthetic where single family homes are increasingly the norm. This is a picture taken right outside of Bangalore. If we were in person, I would ask everyone in the audience where this picture is taken. And many times people think this is taken in California. In fact, this street looks a lot like the entryway into Stanford University with the princess palm trees. But this particular urban built up vernacular is certainly not local to India or Bangalore. Another example is this kind of development that's taking place outside of Beijing in China. Again, the increase in single family homes and a very North American aesthetic that is really becoming quite popular and commonplace all around the world. And again, as Leiwen mentioned, we see that there's a decline in average household size. This is historic data taken from the US, New Zealand, the UK, Australia, and Canada, where you can see that the average household size is declined from about 3.5 in the 1950s to about 2.5 today. And again, I just want to underscore that this is happening all around the world. So we could be looking at China, India, Nigeria. And again, the y-axis would be different. The scale would be different, but the trend would be the same, that average household size is declining. So what does this mean in terms of land and built up infrastructure? This is an image of the world at night from 2018. We've done some modeling work in my lab where we've looked at what these trends mean for land. And our models show that urban land areas are expected to triple between 2015 and 2050. And so most of this area, most of this new land area is going to take place in these 3 countries where there's a significant increase in urban population. But I mean, what this means is that every single day, we are going to see an area equivalent to about 20,000 American football fields converted to urban uses, converted to the built environment every single day for the next 40 years. The good news in all of this is that more than 60% of the projected urban areas that will be in place in 2050 have yet to be built. So there's a significant opportunity to shape the built environment so that the built environment is more sustainable, more resilient to both climate hazards, but also to things like pandemics. But the key point here is that there's going to be a lot of land converted to urban uses. This is going to have a big impact on resources. This is a picture of Shanghai in the early 1980s, Shanghai today. I mean, this is really quite a story, a remarkable story of development, of urbanization, of wealth creation, moving people out of poverty. I look at this, it's also a story of an enormous amassing of resources to construct and build the built environment. This is happening all around the world again. So here's a picture of Lagos in Nigeria, Chennai in India. And one of the things that you can see in these pictures is that there's quite a bit of variation in the built form in the built up environment. There's here in Chennai, you can see that there is a cluster of relatively high buildings, but most of Chennai is pretty low rise. Same thing with Lagos. But if you look at places like Shenzhen in southern China, a lot of the development in Shenzhen is characterized by verticality, an increase in building volume. And this has very different implications for resources, especially for rare earths, especially for the construction of the built environment. And I want to highlight that there's a lot of, there's a big knowledge gap about the urban structure, the urban form, the design that both minimizes the operational energy use as well as minimizes the resources that are required to build, to construct the built up environment. What we have done in my lab is we've been using satellite data to look at the embodied energy and resources in constructing the cities around the world. You can see here, Lagos. Let me just take a minute to describe what you're looking at. What we have here are data from two different types of sensors. On the x-axis, these are data from the nighttime lights data. And so this is Earth at night. And so this is primarily giving us a sense of how much urban areas are expanding in the horizontal direction. It's also primarily a measure of infrastructure. In the y-axis, this is a measure from a scatterometer sensor. It's primarily something that's basically like radar. And it's telling us something about the volumetric change in these cities. And so the arrows that are going upward and the y-axis, that tells us that these cities are growing up, whereas the arrows that are growing in the changing in the y-axis or x-axis, that's telling us that cities are growing outward. And the colors tell us how much of that cell in 1999 was urbanized. And so if we look at Lagos here, you see that there are a couple of arrows that are purple or blue. These are areas that were already quite urban. They were 70 to 90% urban in 1999. And so during the 10-year period between 1999 and 2009, these are places that built primarily upward. So there's a bit of volumetric growth. Khartoum, you can see that there's again, also just very concentrated volumetric growth, but that a lot of growth in cities in Africa are primarily outward. And I want to highlight the gray arrows here. The gray arrows indicate that these are places that were not urban or had very little urban land cover in 1999. So these are places that were, maybe they were agriculture, maybe they were grasslands or fallow lands, but they were not urban in the earlier period. The take-home message here looking at African cities is that African cities are in the early stages of growth, especially a city like Kinshasa. They're growing primarily outward and there's very little verticality. If we look at Indian cities, here's Chennai here. You can see there's a little bit of upward growth. That's probably that cluster that we saw in that picture, that new urban development there. But again, Indian cities are primarily growing outward with a really concentrated verticality in places like in Delhi, in Bangalore. Chinese cities tell a really, really different story, right? So Chinese cities are growing outward, upward. We see Shenzhen, this picture that I showed earlier. Shenzhen is growing very, very high. And you see it, you know, the story of Shanghai. I showed this picture earlier. These places were already urban and now they're growing, you know, they're building upward. So we're in the process of using this kind of analysis to look at what energy costs might be for these cities going into the future, and looking at resources that are required to build the cities of tomorrow. Of course, urbanization is not just about the resources to build the cities, it's also about the resources that are required to maintain the cities. This is a satellite image of Las Vegas in 1976. The areas in red are the vegetated areas in Las Vegas. And even though Las Vegas is in a desert, for those of you who've never been to Las Vegas, there are an awful lot of lawns in Las Vegas and many, many golf courses in Las Vegas. This is Lake Mead here to the east of Las Vegas. I'm going to bring us to the present day and keep an eye on this riparian zone here. You'll see that Las Vegas is going to triple in size and Lake Mead is going to shrink by about a third. So clearly Las Vegas has had this significant change over this nearly 40-year period, and the direct impacts on Lake Mead are really evident in these satellite data. And we're seeing this kind of demand on local resources all around the world, whether it's for water or for natural resources. The UN International Resource Panel published this report 3 years ago, where they took some of our forecasts for urban land expansion, and then they estimated how much raw materials would be needed to support cities in urban areas. And they estimate that the demand for raw materials will more than double over this 40-year period. And they say that such high demand for such raw materials far exceeds what the planet can sustainably provide. So I think the message is quite clear in terms of the raw materials to build the urban environment, that we have to think about building these cities of tomorrow quite differently than how we've designed cities in the past. I'm going to change gears a little bit to talk a little bit about the implications of urbanization on food systems. There are really two sides to this story. The physical development of urban areas has a direct impact on food supplies, primarily through the loss of agricultural land, and really prime agricultural land. This is a picture taken from China, where you can clearly see that these new residential high-rises are abutting agricultural land, but they also took place on what was agricultural land. So there's a direct impact on agricultural land. There's also an indirect impact on agricultural land, because the heat that's generated through cities, through the urban heat island impact, or the urban heat island effect, that actually has been shown to reduce yields and reduce productivity for agricultural areas that remain around cities. So there's both this direct and indirect impact of building cities. There's also a third, or actually a second indirect impact, and that's through nighttime lighting. The lights that occur that primarily exist in and around cities, it's been shown that the nighttime lighting changes the photosynthetic activity of plants and of agriculture around cities, such that yields decline because of a decline in photosynthetic activity, and primarily a decline in net primary productivity. If we look at this globally, we've looked at, so this is some work that we've done where we've looked at future urbanization and what that means for the loss of agricultural land going out to 2030. I should note that in this particular model, we assumed that there would be no new agricultural land brought into production. The good news is globally, we're only expected to lose about 2% of the global cropland. The bad news is that on average, this cropland that is expected to be lost to urbanization is more productive than national averages. But if we look at specific regions and specific countries, the story is quite different. That in specific countries, the cropland loss will be quite acute. So in a country like Egypt, we're expected to see about 1/3 of the cropland being lost to urbanization. And that is because primarily urban development is happening along the Nile Delta, and that is where most of the agriculture exists. In Vietnam, we're expected to see about a 10% loss of cropland. But again, I want to underscore that this model assumes that there will be no new cropland brought into production. We know that there will be new cropland brought into production. And so this points to a set of different questions about what ecosystems will be converted to croplands to make up the loss in production and the loss in productivity. Now, the second side of urban development and urbanization on food systems is really through demand and through changes in diet. A lot of the work in this area, looking at urbanization and diets and urbanization and food, has actually focused on income. And it has assumed that the nutrition transition that's well documented in the literature, the assumption in the literature is that urbanization equals increases in income, and therefore urban populations will undergo this transition, this nutrition transition, going from foraging wild plants to eating legumes and grains to dairy and processed sugar and meats. But the work that we've done in India and in China suggests that if we look at urbanization as a land transition, if we look at urbanization as built up areas, and we look at urban form and urban structure, the story becomes much more complicated. It's not just about income, because how cities are designed has a really big impact on how frequently we shop, where we shop for food, whether we eat at home or whether we eat at work. And so it's not just about the income links, but it's very much about the form, the layout, the design of the built up environment. One of the things that we have found is that in general, urban populations eat a lot more food away from home than rural populations. These are data from 87 different countries, and you can see that as a country's population is it becomes more urban, there's a larger percentage of their total food intake that's taken away from home. There's a number of different reasons for that, including changes in household demographics, changes in the workforce, women working more away from home, the opportunity cost of producing food. So there's a lot that's known about two different aspects of urbanization and food. They're primarily about the loss of agricultural land, and they're primarily about the links between urban incomes and diets. But there's a lot of other hypothesized and known links between urbanization and food systems. And I would argue this is one of the big questions for planetary health and sustainability going forward, is as our global population urbanizes and lives in higher densities, lives in places where maybe they have to shop less frequently for food, Maybe there is more demand for convenient food, for packaging, for cold storage. You know, what are all of these links for food systems and food sustainability? I think there's a big question here. So let me end with a discussion about urbanization and its implications for climate change. And I'd like to give a little bit of a longer perspective on this by giving us a historical perspective about the IPCC reports. So the IPCC reports started in 1990, and up until this last report, which is being published now and next year, there have been 5 reports. And up until 2013, these reports did not consider urban areas, did not consider cities and towns as a primary driver of emissions or of climate change. Instead, cities and towns and their emissions profiles were seen through the lens of individual sectors. So through the lens of transportation sectors, through the lens of building and land and energy. There was quite a big sea change in the 5th assessment report that was published in 2014, in that for the first time, the IPCC report had a standalone chapter on how urban areas, infrastructure, and spatial planning could be part of the solution for mitigating climate change, but also shined a light on how cities and towns contribute to climate change. And one of the big take-home messages, key messages from this report and this chapter is that urban areas account for about 3/4 of global fossil fuel emissions, fossil fuel CO2 emissions. So this is from final energy use. But the report also highlights that there is a lot of variation in energy use across cities. And there are really 2 different reasons for this. One is due to the differences in economic structures across cities. And the other is due to the urban form or the design, the layout of cities. So here on the left, you see this is per capita final energy use for Annex 1 countries, cities in Annex 1 countries. And then on the right, these are for non-Annex 1. So essentially these are developing and on the left, developed and developing countries. And what you see here is in developed countries, the final per capita energy use for cities is primarily below national averages. So in other words, cities in developed countries are quite energy efficient when you compare them to national averages. The story is quite different for developing countries, where the majority of developing country cities have above national average per capita energy use. And again, this is primarily due to economic structure. In developing countries, cities, they are manufacturing things, they're building things, they are primarily a manufacturing economy. They're not a services economy or a knowledge-based economy. So that has a significant impact on the energy use. The other aspect of this is that in developing countries, the national average energy use is relatively low because they're using wood fuel or they're using animal fuel. And so national averages are relatively low. The other reason for these differences is, again, due to the urban design or the urban form. And so we see that cities that are designed to be walkable, accessible, where there's a co-location of destinations and places of origin. So by that, I mean, if housing and jobs are co-located so that commuting time and commuting distance is relatively low or short, that has a significant impact on lower energy use. But we also know that if we look at the total share of the fraction of the carbon footprint globally, that it's actually a relatively small percentage of the global population has a relatively large share of the total carbon footprint. So here you can see that about 30-ish% of the world population is responsible for about 70% of the total carbon footprint. The story is the same if we look at cities. About 100 top emitting cities account for about 18% of the global carbon footprint. But here I want to emphasize that this is for cities that have already been built. This is not accounting for all the cities and all the new towns that we are building and will be constructing over the next 20 to 30 years. But here the point is that there is quite an opportunity to focus and to target mitigation strategies in these top emitting cities to make them more low carbon or to transition them to net zero carbon. Now, 3 years ago, the IPCC published the special report, Global Warming of 1.5 degrees C. And one of the key messages of that report is that the Earth has already warmed 1 degree C since 1850, and that the impacts of a warming planet have already been seen all around the world, whether they are increases in wildfires, especially in the wildland-urban interface, or whether that cities around the world are now dealing with more heat stress. This is a picture taken in Delhi a few years ago when extreme heat literally melted the tarmac in the city. The IPCC report says that we need to reach net zero carbon emissions by 2050, or we're going to overshoot. Now, if we look at the new cities that will be built, and this is some modeling work that the Potsdam Institute for Climate Change Research group did, and others, the Mercator Institute, it's very clear that if cities of tomorrow are built like cities of today under a business as usual, energy use could increase threefold between 2005 and 2050. And so it's very clear that we need to build these cities of tomorrow under a low carbon urban development scenario and not build them like cities of yesterday and the last century. That's the operational, what I just showed in the last slide is the operational energy use. So the energy used to maintain cities. But urban development, urban expansion will also affect the urban heat island. And so work that one of my PhD students did has shown that urban expansion will increase daytime temperatures up to 5.6 degrees C. So this is going to be a significant increase in warming all around cities and due to urban development. And importantly, what we're seeing is that nighttime heat stress is going to increase up to 3 degrees C. And a lot of this higher heat stress is going to occur in cities in the global south. So I'm just going to end with this note, which is that it's very clear that urbanization, urban development, the building of new cities and towns is going to have a big impact on local climates and regional climates as well. But there's a lot that's unknown. And one of the things that the IPCC did 5 years ago at the 43rd plenary is that they recognized the importance of understanding cities and climate change, both in terms of mitigation, but also in terms of adaptation. And for that reason, they approved a special report on cities and climate change in the 7th assessment cycle of the IPCC. So there's going to be a lot more needed research to understand the links between urbanization and climate change going into the future. So I'll end with this positive note that, again, more than 60% of projected urban areas have yet to be built. And so there is a big question as to whether this is a challenge or opportunity for planetary sustainability. Thank you.
Thank you so much, Karen, for this fascinating talk on the challenges with the urbanization. And I think we'll dive into the questions straight away. And there's a question from the audience that also, well, it's basically another question that I had, and they are linked together. The question is it realistic to think that the new city areas that will be built in the near future can be built with considerations to the environment, given how fast this change has to happen? And connected to that, I would also like to ask what the most important things to consider when building all these new cities that needs to be built in terms of the effects on the environment.
Yeah, so I'll take the first question first, whether cities can be built with environmental considerations. It depends. I mean, it depends on the economic development level of that country, but I would say it really depends on the vision of local and national leaders. Yesterday, the president of Botswana was at Yale, and we had a conversation with him about his vision for Botswana. And it's very clear that he has a vision for Botswana to transition to a knowledge economy and to do it in harmony with the environment, because he knows that that will put Botswana on a path to be more competitive for investments, that it will be better for the people of Botswana to urbanize, develop in ways that are more harmonious, have less of an environmental impact. So I think it really depends on the vision, but it also depends on the resources. And I think there's a big lesson to be learned right now with the COVID pandemic and knowledge sharing and technology sharing. It's very clear that we have the technology and the know-how to build cities that are more sustainable, that are low carbon, but that is often not the path that developers take and that individuals take. A lot of the urban development that's happening in the global south is being done informally. It's not being done by developers. Informally, it's not being done by developers. It's not being done by a real estate company, right? It's being done by individuals. And so that will have a very different set of challenges in places where urban development is more informal. In terms of the other question, can you remind me the second one?
It's what are the most important things to consider in terms of the effects on the environment when building all these new cities that are waiting to be built?
Yep. So it's very clear that the urban design is one of the most important things. Thinking about where people live and where they will work is essential for low carbon cities and just a lower environmental footprint. So there's a land component to this, there's a resource and energy component. And so we design cities so that there is this co-location of people and places that has been shown to have a really big impact on lowering emissions and lowering the demand for resources, not to mention saving land for nature, right? So it's really making sure that cities are compact, but it goes beyond making them compact, because just as an example, many Chinese cities are very compact and they're incredibly dense. One of the challenges with Chinese cities is that they are not designed and zoned so that there's co-location of people and places, work and jobs. I lived in Beijing for a while, and I literally was commuting an hour to get to where I needed to go. And that is quite common in many of the large Chinese cities.
Mm. And in many cities all across the world, I would
and in American cities, right, as well.
Yeah. and that brings me a little bit to there's one thing about the environment outside the cities, but also the environment in cities, and how people that live in these cities are doing, and how they, and so when it comes, I'm not really, you haven't said that dense is the way to go, but there's a lot of interpretation by city planners and leaders that it should be dense. But can you say anything about, we still need, the populations in cities also need green areas to feel good, and possibly if you build in possibilities to grow food, you might solve some of the problems with the food issues, but I don't know how the potential is for that. But can you reflect a little bit on that?
Yeah, so I'm glad you mentioned density. I didn't touch on that in my talk. Density is a really complicated issue because you could have the same level of density, but for two different cities, but if they are configured differently, so just as imagine you have density where everybody is living in one building, one tall building, and they are zoned, they all work here. So they're traveling really far. That has a very different environmental impact than if there are lots of low rises and people are living very close to their work, but they don't have to travel and live in these very tall buildings. It's much of the literature shows that it's the 3 to 5 story development, that type of density, that is almost the sweet spot for lowering environmental impact, but also are healthy for people in terms of lowering the urban heat island impact, also allowing for green space. There's a very interesting set of literature on the psychological and physiological impacts of living in tall buildings. So buildings that are 30 stories and above. I mean, you're primarily only seeing this in East Asia. So there are some negative consequences, more mental consequences of living in very tall high rises, but also being completely disconnected socially and living in these tall high rises. So density alone is not good. It's density combined with these layout and design of cities. If we look at some of the densest cities that have around the world that are positive examples of, again, this sweet spot, Paris is often used as an example of a dense city, but that still has green space. Taipei is another example, Bangalore. So cities don't have to be dense and have a bunch of tall high rises.
That sounds good, to me at least. Let me see if we have any other questions from the audience here. Leiwen has posed a question to you, and that's: how may the changing climate system affect urbanization trends in the world and different global regions?
Yeah, well, I'm going to talk about this primarily in terms of thinking about the built up environment and not about migration, because of course, Leiwen, you're the expert, and Wolfgang and others here are the experts on that. But there's some really interesting work that's being done that's showing that changes in extreme events is changing how and where people are building within the city. So some people may be moving, so there are certainly some climate migration trends, but in terms of people moving to different parts of the city or to different types of the built environment, that is something that we're seeing all around the world, that people are wanting to move out of the center of the city and moving to more of the suburbs, to places that are maybe less hazardous, also places that are less hot. I mean, that's something that's coming out in a number of different surveys, is people in cities are concerned about heat. And the other thing that is a big question is, our concern is wildfires. I mean, we're seeing that here in the US and Western US, especially wildfires in the wildland urban interface. And so there will be a lot of questions about whether people should be building in these places that are really right next to these wild and forested areas.
Thank you. And well, I think we'll take one more question. That's actually from another co-speaker, which will come tomorrow. And can you give examples of the most important aspects of LCUD? I'm afraid I don't actually know what that is, but this is from Laurie Hunter. Sorry, I should have said that. What does this suggest about migrationism? Yeah.
So that's the low carbon urban development, right? So that's what I was talking about earlier. It's really important. The design is really important, but the other is the materials that are being used will be really important, because the materials that are used to build the built up environment has a big impact on the heat retention, thermal heat, and the urban heat island. So the key aspects of the low carbon urban development are about the materials that are used in designing the buildings, as well as the layout of the buildings.
Thanks. There are so many interesting questions that we cannot take right now, but I hope there'll be some time in the panel to go back to some of these questions also. So be patient with that. But for now, I want to thank you, Karen, a lot for this talk and this run of questions. And we will now take another 10-minute break. So I hope you will join us again 5 past the hour, wherever you are. Thank you very much. So welcome back to this seminar on population and environmental change. We have heard 2 great speakers already, and we're ready for the 3rd one. But I would remind you to please keep posting questions in the chat. No, not in the chat function. Sorry, in the Q&A function on Zoom, if you are with us on Zoom. Our next speaker is Eric Lambang, who is a geographer and environmental scientist. And he divides his time between the Université Catholique de Louvain and Stanford University. His research tries to better understand causes and impacts of land use changes in different parts of the world. And in 2019, he was awarded the Blue Planet Prize. And he will give us a talk now on population and land use from coupled to telecoupled systems. You're welcome, Eric.
Thank you. Okay, so do you see my screen? Okay. Okay, I'm assuming you're seeing my full screen now. So thank you very much for the invitation. And I was asked to talk about the interaction between population and land use. And of course, I'm excluding urban land use because Darren Seto just discussed that brilliantly. And I have to say at the outset that this nexus between population and land use is not anymore an extremely hot, active area of research for reasons I will explain in a few minutes. So what I decided to do is to revisit some of the very classic studies that have looked at that issue a few years ago and extract from that a few key insights. Some of the key points I will discuss, I would like first to start by stating the obvious that, of course, at the global scale and over the broad sweep of history, more population means more land being used. It's clear that in a world with 1 billion people, there would be less forest and natural habitat being converted than in a world with 10 billion people. Quite obvious. But when we look at this nexus between population and land use at a finer scales, then we see a much greater complexity. And I will mostly focus my talk on these finer scales of analysis. And there indeed you find some very rapid land use change, both associated with increase or decrease in local population due to many interacting variables, which I'm going to discuss. Another kind of point that I will discuss throughout my talk is that in most situations, population is more a cause than an effect of land use change. That is to say that population, or at least fertility, seems to be largely an exogenous variable. I will come back to that. So the outline of my talk, I will first discuss what I feel is a magnificent, beautiful study that have really looked very, very carefully at the association between population and land use in a mountain environment, very marginal conditions. Then I will discuss a few other studies that have highlighted three paradoxes on the link between population and land use. One study shows that more people can be associated with less soil erosion. Another one that less people can be associated with more deforestation. Another one that more people is associated with more forest. And in all three cases, I will identify the theory or the concept that are underlying these relationships. Also, the concept of telecoupling that I'm going to introduce next somehow accounts for these paradoxes. And then I will finish by addressing this land use population feedback. Okay, let me start with this study that, as I said, I find it absolutely excellent. And if, like me, you like to hike in the mountains or in the Alps in particular, this is a must read because it really gives a detailed account of the land use and the demography of a very ancient Swiss alpine community in a small village called Törbel. And the author, an anthropologist, Mark Netting, did spend several years living in that community, and he had access to about 3 centuries of annual records on the demography and the land use of that community through the records of the parish, of the municipality, and other sources of statistics. Like many other mountain communities, this one is very isolated from the rest of the Swiss economy. It has very high altitude, steep slopes, sun illumination constraints, water constraints, especially in summer and fall, and a very limited constrained territory, limited land. And these people were gaining their livelihood from livestock, not many, but they each had a couple of animals, basic cereals, and also they had their home gardens next to their house where they were growing vegetables. They used quite a sophisticated technology, but mostly based on human effort. So the technology was more about the knowledge on how to manage these restricted resources rather than deploying some machines. And Robert McNetting used a lot in his book the word of the concept of close corporate community, just to highlight that this whole community really functions like a corporation. It has to be tightly integrated, tightly managed to maintain sustainable land use over the long term, which they managed to do very nicely. Based on this detailed reconstruction of demography, we see a kind of slow rise of the population. The population of Törbel doubled, more than doubled, over a 250 years period. You see, quite some stagnation of the population for a while, and then some period of acceleration, some short declines here, and then in the end, some out-migration that explains this decrease in population. On the right panel, we have the out-migration from the community. And again, you see for at least a century, more than a century, almost no out-migration, then little burst of out-migration until the mid-20th centuries, where suddenly the community starts to be open to the outside world. Some other features of the demography of that community is a remarkable continuity in the family lines, and just great effort to maintain this family line. quite a high age of marriage, around 28 for women, 30 on average for men, but that was not uncommon for Europe at that time. Quite a high rate of celibacy and some migration, as we see on this graph. What were the strategies for land use? Well, the scope for expansion was extremely limited. Tyrol had a clear territorial boundaries marked actually with stone walls. So, they are very visible in the landscape and very hard to move. So they were restricted, in terms of land access. The only thing significant that happened is when the community as a whole acquired a high altitude Alp around 1514, but quite remote from the main village. It was 3 days of march. And so when you transport your livestock, there was a significant labor investment. So the main strategy to accommodate this slowly growing population was through intensification. And this system was quite intensive to start with already in the Middle Age. But over the years, they became even better, even more refined in the way they were managing water, soil through manure application. And the major constraint for intensification was the availability of labor. So on one hand, they didn't want the population to increase too quickly, but on the other hand, additional labor was always welcome to manage this very constraining environment. The only significant change that happened in terms of food supply was the introduction of the potato in the late 18th century. That was associated with a slight increase in population. But also, as always in these communities, regulation, institutions, social rules on things like who is admitted to settle in the village, how the commons, the common resource, the grasslands are being managed and conserved over the years. How is property, land, being transferred from one generation to the other? How are decisions made at the scale of the communities by involving all the stakeholders? So all these institutions were extremely sophisticated to again ensure this balance between population and land use. Let me just show this rather long, and sorry for that, but rather long quote from the concluding chapter of this book. And the reason why I'm showing this, because that was written 40 years ago. But today, I think we could write almost the same thing by changing just one word or two about many, many rural communities in the world. So he says there's no indication that the people of Tyrol ever worried about exceeding environmental carrying capacity or consciously attempted to limit internal population growth. So this is really to say that the population fertility is largely exogenous. Rather, their intentions were built on desires to acquire property, produce food, find a mate, raise children, keep the respect and cooperation of their neighbors. Something that would still apply to most of us today. Most of us would still follow these objectives. Their strategies for pursuing these aims were congruent with the potential for continuing exploitation of a demanding alpine environment. So really the endogenous variable here is land use and institutions, how to manage your land and how to design social rules in order to maintain this balance. Okay, let's move now to this paradox found by other studies. Let's change continent, move to Africa in the Machakos district in Kenya, where another very detailed studies, also long-term, but only 60 years here, while the previous one was 3 centuries. And the slightly provocative title of the study is More People, Less Soil Erosion. In the Machakos district here, population increased much, much faster than in Tyrol, in the Alps, more than 3% per year, more than 5-fold population increase over that time period. And yet this author in this study describe, based on good data, how they observe a restoration, a recovery of the environment despite this rapid population increase, mostly in the form of new and better managed terraces to control soil erosion on the cropland, better practices for water conservation, tree management by these smallholders, a much clearer demarcation of the land and registration of the grazing land at the level of the communities and villages. And also, notably, better market integration. Over that time period, these communities start to be much, much more integrated through the markets. They invested into new cash crops, coffee, vegetables, some fruits. They start to sell these cash crops to the local market. And this was a quite profitable exercise. This led to a threefold increase in the value of output per capita, a tenfold increase in the value of output per hectare, just an incredible increase in land productivity, measured in value here, as you note. And also, same as we saw in the Alps, strengthening of the family and the social institutions to improve cooperation between households and villages. This story is really a story of agricultural intensification, defined as higher level of inputs and increased output of cultivated land per unit area and unit of time. And as you know, in the definition is increased output in quantity or in value. In the case of the Machacos district, it was largely in value thanks to the marketing of these commodities. There's a very well-known relationship between population density here in the y-axis here and the length of the fallow periods in the farming systems. In sparsely populated area, you tend to have these very, very long fallows, 20, 25 years. And as the population density increase, people have to intensify their farming systems to make space for the a new population. And this is associated with a shortening of the fallow, which is compensated by more inputs, more labor input, more external inputs to maintain the fertility of the land. This is known, this was formalized by an economist, Esther Bastrop, in the 1960s. And this is known today as the Bastrop Thesis. She shown that the change in technology is stimulated by increases in population. In other words, the intensification of agriculture that was seen in the Machacos district was there to alleviate the population pressure. So in other words, the technological change in the adoption of these new land use practices is endogenous, while population increase is exogenous. And she adds another element to her thesis that the increase in the intensity of agriculture leads to a decrease in labor productivity. At least that holds for non-mechanized farming systems. That is, the intensive farming systems have a low labor efficiency. You have to increase quite a lot of your labor in order to reach a small increase in output per hectare. And if you assume that farmers maximize their labor productivity, they would tend to adopt the most extensive system allowed by the population density. So they would be under a quite extensive system. It's only under the increase of population that they would do the effort of intensifying. And of course, again, this only holds for non-mechanized systems and also for farming systems that are poorly integrated into a market. If you're selling for the market, you have an incentive to intensify, even if your population density is pretty low. So we can summarize this by this graph here. There's the space between population and technology, we generalize. And going from the left to right, so on the left here, you are overdeveloped. You're overdeveloped, you have a high level of technology, remember, which depletes your labor productivity, even though your population density is too low. So it's unnecessary to be so intensive. Then you are in this ideal envelope here, this ideal space, where you have just the right level of technology for your population. But then if you're on the right-hand corner here, that's why you're in trouble, because you have a high population with a quite low level of technology, of farming technology, and now you're degrading your land, and you enter a vicious circle of land degradation. Okay, second paradox. Another set of studies show that actually less people can be associated with more deforestation. Now, there's this very widely held view that rural population density is correlated with deforestation. Seems logical, seems very intuitive. However, especially over the last couple of decades, the causes of deforestation are increasingly non-local. Deforestation is increasingly linked to distant factors. Let's just look at the biggest hotspot of deforestation in the world, Latin America, Southeast Asia, and you have these very large zones with low population densities that are big commodity frontiers. Look at these big soybean fields. Well, no one lives there, and yet you have massive deforestation associated with the expansion of such system. Same if you would go in Southeast Asia, you would find the same with palm oil plantation expanding quickly. But these are all commodity crops that are exported, of course, outside the country. There's also in the literature, mostly in South America, this concept of hollow deforestation frontiers. In the forest frontiers, the colonization to forest areas, some places are being depopulated when the pioneer, the colonists move away and their land is being taken over by cattle ranches. Very, very extensive operation, not even one head of cattle per hectare, very low population densities, and yet these are large areas converted from forests. So the main reason we find that is that, of course, demography, population is one of the causes, underlying causes of land conversion, forest conversion, and other forms of conversion. But it's just one factor among many other factors. And these factors do interact, whether we talk about economic factors, new technologies, policies, institutions, cultural factors. And together they influence a set of proximate causes. And that's probably why, I start by mentioning that the study of the link between population and land use is not such a hot topic anymore, because now most scholars working on these topics really have integrated the fact that you need to adopt this system view and look at the interaction between multiple factors at multiple scales, rather than focus on just one category of these factors here. Among these, the economic factors play a key role, especially the ones related to global trade. And today, a very large fraction of deforestation is associated with commodity crops. These are data from my colleagues in Chalmers University in Sweden. And we look at the share of total deforestation in these three parts of the world associated with different commodities. And if you look at Latin America, very, very large, up to 75% of the deforestation is associated with cattle, these very extensive ranches, soybean, a little bit of palm oil here, and also some of these coffee and cacao crops that are also commodity crops for export. If you go to Asia, the share of palm oil is much greater. You also find the cacao and coffee and some meat production. In Africa, you find a much greater share of staple crops for the domestic market. But this is to say that the drivers of deforestation today is exactly as Karen explained just in the previous talk, are being decided in the big cities of the world, in the big cities of Europe, North America, China, and other places of Asia. That's where the new diets, more rich in meat, in sugar, in vegetable oil, is being shaped. That's where the new lifestyles are being decided. So the drivers, the driver of deforestation are distant and unrelated to the local population densities. Third paradox, in some cases, you can find more people with more forest. Another classic study here by excellent geographer, the late Alexander Mather, who in the 90s started to study quite systematically what is named today the forest transition, the shift from net deforestation to net reforestation at the national scale. And Mather and his team looked at a number of case studies, mostly in Europe at that time. So this is the case of France here, and painfully, he reconstructed the forest cover curve over more than 10 centuries here. We go from 1000 to the year 2000. So this is this line here, and the population curve at the same time. So what we see is that initially, from 1000 to 1300, the human population in France more than doubles, and the forest area decreased by about a factor of 2. So almost a linear relationship between population and forest cover. But then disaster strikes, the Black Death, plague kills about 30% of the population in France, and you have a first forest transition, a first recovery, a shift from net deforestation to net reforestation, known as the medieval forest transition, that's purely driven by demographic factors. But this transition is short-lived. Then we go back to a long phase of deforestation, forest clearing, and during that time, Colbert, was one of the main ministers of Louis XIV, the Sun King of France, famously declared France will perish for lack of timber because we're destroying our forests much more too rapidly. And Colbert designed the third forest ordinance, which is largely ignored, not implemented, very little compliance. So it doesn't have any effect, and forest cover keeps decreasing very fast. And in fact, it even accelerates with the French Revolution. But then in the early 19th century, we see a second forest transition, another shift from net deforestation to net reforestation here. In this case, it's associated with an acceleration of population increase. If you look at the population curve, it just increases, while the forest increase at the same time. So more people, more forest. What happens there? Well, it's the shift with more intensive agriculture, new technologies, the Industrial Revolution, some exodus of the population from countryside to cities, the use of coal as a fuel to replace fuel wood, therefore less pressure on forest, and finally the famous forest ordinance of Colbert, not exactly in that same form, but this started to be implemented and regulate forest use in France. Today, or not today, over the last couple of decades, we found very similar forest transition in developing countries. If we look here at Costa Rica, this is the curve of forest cover. Also this very clear reversal of the forest cover trend. Same in Vietnam here, a clear turning point, as the population of these two countries was still increasing. Definitely the total population was increasing, and in Vietnam, the total plus the rural population, while the latter in Costa Rica was more stable. Remarkably, in Vietnam, as the forest cover increased, the area on the cropland also increased slowly. What happens there in the two countries are multiple things. One is an intensification agriculture. In Costa Rica, we shift from cattle ranching to a more high value fruit, bananas, pineapples, palm oil. In Vietnam, we see a shift from the slash and burn cultivation in the mountains to intensive rice cultivation in the valley bottoms with irrigation, much more intensive. We also see some redistribution of land use at the scale of the country. But then we see something else also in all of these forest transition countries. What we see is that as these countries protect their forest, in Vietnam, they had this logging ban in the 90s. At the same time, they start to import more timber from the neighboring countries. At that time, if you would be standing at the border between Vietnam and Laos or Cambodia, you would see these trucks full of timber passing the border day and night, nonstop. A lot of this trade was completely illegal. So basically what Vietnam did, it did export its deforestation by importing timber from its neighbor. And so that facilitated, of course, the forest transition in the country. We've estimated the volume of imported timber in Vietnam, and we compare this amount to the total wood volume that was conserved in Vietnam through the forest transition. And so this imported timber, this exported deforestation, is about 40% of the total wood volume that was preserved in Vietnam. So we can say, you know, the glass is 60% full, real forest transition at the regional scale, and 40% empty, just shifting across your border, your deforestation. So that's what we call spillovers, leakage, or land use displacement, when land use decision in the place lead to a migration of activities to another place. And of course, you understand that these processes are largely decoupled from the local population. They are coupled to the consumption. And again, consumption in the cities, largely. So we find again, you know, what Karen was telling us about the cities driving food consumption, resource use well beyond their border and even beyond the border of the country where these cities are. Even a small, very remote, closed economy like Bhutan, even there, we did quantify some very significant land use displacement. The population of Bhutan is growing slowly at the rate of 1.1% on average. A highly forested country, forest quite well managed. And you see, you know, the wood production in blue here and the wood consumption in green year after year. And these two values more or less, you know, are quite similar, more or less balance each other all the way to 2006. And now suddenly in 2006, consumption of wood increased. So there's some urbanization in Bhutan, some small industries that start to develop there. Forests are being better protected, so the wood production decreased. So how is this shortfall being met? Well, again, simply by importing wood timber from its neighbor, India, mostly in the form of charcoal. So quite interesting that even a very small, isolated, remote kingdom is also displacing its land use to outside its border. You know, it's kind of offshoring of its land use. Well, this leads to this concept of telecoupling. You're all familiar with the concept of coupled human and natural system. You know, this interacting human system with the natural ecosystem. You know, this kind of two-way relationship. While in telecoupling, these interactions occur over long distances, via trade, via some flows of capital, of commodities, of people, of information, of value, etc. A key concept that was proposed by Jack Liu. And basically that explains all the cases I've been discussing so far. You know, if you remember Kenya, well, the more people, less erosion was possible because they were connected to a market, to an external market. The case of, which one was the next one, of France, also suddenly, you know, you have the regrowing forest in the countryside because you have this exodus toward the cities. Vietnam, you know, you import your wood from Laos and Cambodia. Costa Rica is slightly more complex story. I don't have time to go there. But so this telecoupling is also the source of the decoupling between local population and land use. That's the world we live in today. You know, this is a map of the flows, trade flows in food commodities, expressed not in quantity of soybean or palm oil, or not in value, but in terms of hectares, millions of hectares equivalent in the producing countries. Okay, so here we see China importing the equivalent of 12 billion hectares of land under cultivation in Brazil. Okay, so this is the world of telecoupling. Okay, so again, so that explains, you know, the finding that we have a weak or inconsistent relationship between population and land use. Let me end here by discussing this question of the feedback from land use to population. Can we find evidence that as population cause change in land use, which itself cause change in land cover, can we find evidence that this is affecting land use decisions in a way that would modify population? Well, clearly in an urban context, yes. You know, as you move to a city, household size decrease, family size, fertility decrease, education increase. So you do have this feedback when you move from countryside to cities. But if we ignore that aspect, if we look at the rest, personally, I've just have a hard time, coming with very, very strong evidence that this feedback is a very, very strong, connection. And I'm well aware that, economists in particular, have this view of the world in terms of general equilibrium, that most variables are endogenous, that you have this cascading effects through the system. But that's one connection that I'm not saying it's inexistent, but seems to be weak in my view, and I'm happy to discuss that during the discussion time. Maybe one case where I could argue that this is taking place is when a change in land use by some activities transform the landscape to a point where it changed the habitat for some disease vector, for instance. Suddenly you have an increase in dengue fever or Zika, in peri-urban areas because you've changed the landscape, you've changed the habitat. And so that has a feedback on the human population. But probably more in terms of behavior than in terms of population numbers. So if we go back to this causal chain, so population causes some land use change, some land cover, and this creates an ecosystem disservices. So this is creating suddenly the rise of the risk of vector-borne disease transmission. Okay, and so now this will affect land use decision. But what we would see, and we've done some studies on that. First, people will change their behavior. They will adopt protective measure. They will use bed net. They will change their land use practice. Second, they will try to eradicate the ticks or the mosquitoes or the vector of the disease. And then only in extreme case, we will see some avoidance of places with disease risk to the point they would be abandoned. Maybe people will shift the time when they go to their field, or they will avoid the sunset because that's where these malaria transmitting mosquitoes are more active, or they will change behavior, but really a complete change in land use due to that feedback. It's not something personally I've observed dramatically. And of course, even if we would observe this connection, we have many exogenous factors that affect land use, that affect disease risk, that affect land use decisions, that really blur very much that feedback. Okay, my time is over. So in conclusion or in summary, I think I've started by saying that the association, this nexus between population and land use really depends on the scale of analysis. Second, I hope I've clearly demonstrated that we need to consider the population and the consumption of the full telecoupled system, which today is basically the global system. Very few places are isolated today. And as we do that, we have to consider many interacting co-variables, including commodity trade, institutions, consumptions, lifestyles. And in my view, in most situations, fertility is more an exogenous variables with respect to land use, and land use is the endogenous variables. And in terms of demography, sure, migration, some behavior, will be related to family or land access, will be the adjustment variables to maintain that balance between your population and land use. Thank you very much.
Thank you very much, Eric, for this both historical expose of your field and also of the explanation of the telecoupling that's going on today. And we have some questions, so we will start with them. And well, it's actually, again, I have a reflection, but this also is connected to this question. What do you think? Oh, sorry. What do you think the global trend of forest cover might look like in the future, based on the very diverse scenarios of forest cover change that you have described?
Yes, good question. And I'm not so much in the kind of scenario making myself, but we've seen, this forest transition happening in the advanced economies all over the world. We start to see them, big time in China, India, Vietnam, Costa Rica, a number of emerging economies. But to the extent that these countries are allowed to regrow their forest by buying more timber from elsewhere, then basically, de facto, it will always be associated with increasing rates of forest cover change elsewhere in the world. Now, if we look at the available solutions, we can really create a world with growing population, growing consumption, and stable, or if not, regrowing forests by some very simple change, such as a diet that's much more, that's less carnivorous, more vegetarian. If you remember one of the graphs I've shown, cattle is the major proximate cause of deforestation. So it would just stop consuming meat, would probably solve already 80% of the deforestation problem. Also, it's something that on paper looks quite easy to fix in terms of governance, because you have so many win-wins. As you protect forests, you increase biodiversity, you protect a number of ecosystem services. And yet it has proven to be a very, very hard nut to crack. There's been 20, 30 years of efforts to control deforestation with many actors involved now, private, public, local, international, with very, very little success so far. So I'm afraid we still have a couple of decades of degrading forests, but hopefully eventually we'll be able to turn things around. Yes.
And would you say, I mean, you've given these examples of how less population can still mean more forest and vice versa. But if you look globally, from what you can see today, if you look at the population increase and the forest cover, what is the connection there?
Yes, it's not so much population per se, it's more the consumption, the diet, the lifestyle, the urban lifestyle, the need for construction materials. So I think that's where the connection is more related to the consumption, which makes it on paper, a much easier problem to solve, because it's easier and faster to shift to a more vegetarian diet than to bring the world population to a stable level, because we know there's enormous inertia in the demography.
And then, of course, it's more complicated than that, because it's not just forest cover per se; it's where the forest cover is.
Exactly.
Also.
Yes.
Amazon being such an important climate stabilizer. So depends on where the forest cover is as well, I guess. So, and this is a question from Laurie Hunter on land use influencing population. There's an emerging literature on how land and resource scarcity is influencing fertility, desires, and behavior, although much more to be done. Any thoughts on that potential?
Yeah, I hope Laurie will talk about that tomorrow. Maybe not. I know she's talking about migration. Yeah, so as I said, so far I've seen very little hard evidence on this connection, but I know that this is being studied, and evidence is not hard to come about, because you have so many confounding variables here. But let me send back the ball in the camp of Laurie and hope she will mention something about that tomorrow in her talk.
And now we'll take a question again about forest cover, which is not the only thing that you're studying, of course, but this is what your talk was a lot about. But the question is, what about use of timber to build cities that is now being discussed, the more environmental and climate-friendly alternative to concrete and similar materials? Can you comment on that?
Yeah, no, and that's, of course, an excellent idea, because as Karen mentioned, concrete, sand extraction, cement production is one of the major source of greenhouse gas emissions, CO2 emissions. So we need to replace construction material and taking timber. They are very efficient store of carbon. So bringing timber into construction material is one way to create this stock of carbon for several decades. And if you remember one of the graphs I've shown, the wood extraction under good forest management practices is not a major source of forest conversion. Often when it's well done, it's part of a cycle. So you extract the trees that are mature, but then you plant new trees, you have this rotation. So you can do that in a way where you manage your carbon stock in a forest that in a pretty stable way. So I know many people have the conception that timber extraction is the major driving force of deforestation, but not at all. It's really these commodity crops, cattle, palm oil, soybean, which are.
Right, and I have a question from Leiwen, and who's also thanking you for a great talk, by the way. Is it fair to say that the period of more people and less erosion has passed in almost all regions under the globalized world? The world is in a later stage of forest transition. What is the role of population concentration and urbanization in the process?
Yes, I would not say that the more people, less erosion era is over, because there's still many parts of the world, and I'm thinking especially in sub-Saharan Africa, where you have smallholder agriculture with a huge scope of intensification. You can still greatly increase the efficiency of these farming practices and therefore spare some land for nature and bring more prosperity to this household, and therefore maybe accelerate the demographic transition as well. But again, I link what I said to Karen's talks, where the source of demand is in the cities today. That's where it's growing, and so the way the value system, the lifestyles will evolve in the cities will largely determine what happens in these more remote countryside regions. But it works both ways. If there's a demand, as we can see now, at least in some part of the world, for more sustainably grown coffee, cacao, that can foster the adoption of agroforestry practices or zero deforestation commodities, the urban lifestyle and value system can actually accelerate this forest transition. And if in addition, there's some sound investment into new agronomic practices and the adoption in this remote part of the world, that will further accelerate this transition.
Thanks. Let's see. So I think we'll have time for one last question. And that's a question that looks forward. What do you think will be the next trend in the relationship between demographic land use and climate change? So can you see an upcoming?
Yes, well, the total land use sector is responsible for about 20% of all the greenhouse gas emissions. Forest is about 10%, agriculture, and the rest. There's a lot of talk today about the so-called nature climate solutions, how to store more carbon by improving land use practices, and such as avoiding deforestation, reforestation, carbon capture into the soil, using things like biochar. And this has some potential, but let's not be too optimistic there. We talk about a few percent, and it's just to help, but it's not going to solve the problem. But on the other hand, there's a big worry that today, the biosphere as a whole is absorbing about 50% of the CO2 emission that humanity is emitting. And we already start to see some large biomes, such as the Amazon basin, turning from a carbon sink to a carbon source, a net source. So the careful land use management is absolutely essential, if not just as a nature climate solution, but at least to maintain this incredible service that land ecosystems, terrestrial ecosystems, are providing to us, just by taking such a large fraction of our emissions and storing that long term.
And from your perspective, can you see any indication that this is being done, that the people in charge are actually starting to?
There's plenty of indication that we talk about it, that there are projects, programs, plans, declaration, commitments. So we have plenty of that for sure. What we don't see yet enough of it is actual change on the ground. The outcome. The rates of deforestation are still really, really high and accelerating in some part of the world. If you look at the Brazilian Amazon for the last couple of years, So yes, I think no, I'm happy to see so much interest and political action against that. But no, it has to go beyond the declaration, and it's not easy to get the governance right, because it does involve multiple levels of power, from local to national to international, multiple actors, indigenous communities, big companies that are buying all these commodities, and investors, the financial world. So how to align the interest of all these actors to actually solve the problem on the ground and not just on paper or in the international forum. I think that's really a big challenge for the years to come, not for the decades to come. That would be too late, for the years to come.
For the years to come. Yes, thank you very much. And we hope that the UN Food Forum that is going on now next to Leiwen Young's offices in New York, maybe they will get some small steps on the way in the right direction at least. Thank you very much, Eric. And thank you everyone for taking part in today's discussions and seminars. And we hope to see you again tomorrow at the same time, 1500 CEST, Central European Summer Time. And keep sharpening your pencils for those questions that we want coming in. And again, thank you everyone for being here, and see you tomorrow.